All right, so we're going to start off with chapter 10, which is solving linear equations. Okay? Now, for those of us that aren't sure, first of all, what is a linear equation? Okay, because that's an important definition for us. A linear equation. Okay, linear means line. Okay, so what that means is if I were to graph the equations that were given, they would make a line. They'd make a straight line. Okay, and that's pretty much the types of equations that really you are going to see for the next couple years here. They're going to be linear equations. They're going to be line equations, right? So that'll be easy to graph and they'll be easier to solve as well. Okay, so the official definition of a linear equation is an equation when graphed results in points that lie along a straight line. Okay, so and we're going to be solving these equations. Okay, so the next thing that we have to look at and remember is what is a variable? Okay, a variable is a symbol we give to an unknown value. Okay, so for example, a variable could be X, it could be Y, it could be J, it could be R, it could be any sort of letter, okay? Once you run out of letters, it can be that symbol, it can be this symbol, right? It can be anything really. We use a bunch of symbols, okay, to represent a value, okay? So a value that we don't know. So it's kind of a placeholder, right? We're putting that value in. So let me write in a linear equation, for example. Let me say 2x plus 5 equals 10, okay? 2x plus 5 equals 10. So, right, we need to figure out what is X, okay? X stands for this unknown. It's that question mark, okay? So 2 times question mark is, plus 5 is going to be 10. Okay, so we have to figure out what is this question mark, okay? And that is pretty much this whole chapter, is trying to figure out what is the question mark with different types of equations, because they're going to look differently and we need to figure out how to solve them, okay? So the first thing, okay, that we're going to look at is just the format, okay? So I'm going to write a linear equation. So the first format we're starting with is going to be this one. Okay, so you're either going to see ax equals b or x divided by a equals b. Okay, so remember x is that variable, that's what we're trying to figure out, and a and b are numbers. Okay, so in this case we got 3x equals negative 12. Okay, and this is where you got to remember your integer multiplication and division, subtraction, etc., because we're going to be using it in this unit. Okay, so 3x equals negative 12. So what this means, first of all, if we were to break this down, this would be, let me use a different variable, okay, just so we don't get confused. Let's say 3a is equal to negative 12. Okay, a is still the unknown variable. It doesn't matter what you call an unknown, okay? It still represents an unknown, okay? So what this actually means here is 3 times a equals negative 12. Okay. So as soon as we break it up, this is like what we were doing before. All year we've been doing, 3 times a question mark equals negative 12. Okay. And so we can look at it in terms of fact families for these types of questions. All right. For specifically this section, we can use fact families, okay? And fact families are going to explain to us why we're doing something, okay, once we actually get to it. So 3 times what gives me negative 12? Okay, we said, well, okay, if we're going multiplication this way, we can do division backwards to find that unknown, okay? So 3 times something is negative 12. That's the same thing as saying, okay, if I need to figure this out, I go backwards, I go negative 12 divided by 3 is going to give me that something. Okay, I can go either way, okay, forwards or backwards. So 3 times something gives me negative 12, or negative 12 divided by 3 is going to give me that something. Okay, that's our fact family. It's what we've been learning all year. So now negative 12 divided by 3, so ignore the integer for now. 12 divided by 3 is 4. Okay, and a negative divided by a positive is going to be negative. So in our case, A is equal to negative 4. Okay, so simply just doing that opposite operation, writing it out as a sentence. Okay, if you look up here when we wrote 3A is the same thing as saying 3 times A. They mean the same thing. Okay, this is the exact same thing, but we write it this way because it's less confusing. Because what if it's 3x? Well, now it's going to look like 3 times x. That looks confusing, okay? So we don't do this. That's how we write multiplication, okay? We know that that's kind of a shortcut for us. Right, so the first way to solve that equation is using fact families, okay? There's going to be 3 ways I'm going to show you, okay? Fact families is kind of just for this specific section. We can look at it through fact families, and they kind of explain to us why we do these next 2. Okay, the second way I want to show you is through modeling, which we need to know how to do, okay? How do I actually model what's happening, okay? Well, if we take a look at this, again, we get 3x equals negative 12. We're going to use our algebra tiles to represent this, okay? So this is our equation. Great. Okay, so we're going to use algebra tiles. So I'm going to say this, the longer thin ones. Oh boy, I'm going to actually use a shape because this is bad. My drawing is not impeccable, as you all remember, I'm sure. There we go. Good. Good. Awesome. So what we do is we're going to use algebra tiles. Okay, so now to write my legend, I'm actually going to try and draw this legend here. There we go. This represents x. Okay, so the thin, longer rod represents x. The small little squares represent 1. Okay, so just one piece. Okay, x is that unknown. So how many unknowns do we have in this case? Okay, and then we use different representations to represent positive and negative. Okay, so for me, my shaded in ones are going to be positive, and my non-shaded in ones are going to be negative. So be negative x. Okay, again, my positive shaded in are positive 1. Oops. And my non-shaded in little squares are negative 1. Okay, so that's my legend, and that's what I'm going to be using from now on. Okay, so if you're ever confused, I'll try and repeat it every single time. Okay, but shaded in are going to be positive, and non-shaded in are going to be negative. Okay, it can really be anything. They can give you colors or whatever. That's just what I'm going to use today. Okay, so now to represent this particular equation that we've been given, how many x's do we have here? Well, we have 3, and they're positive. So I need 3 of these colored in ones. So I've got 1, 2, 3 colored in, okay? And they're going to be equal to 12 negative ones. Okay, so they're not going to be colored in, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Okay, I've got 12 negative ones. Okay, and then I have 3 positive x's. Okay, now they have to be the same. Okay, what that means is that 1x, okay, I have to make them the same. So we want to figure out how many of these particular little squares here, if I was to move them, how many of them fit into that 1x? Okay, that way that we use all of the x's. Okay, so when I do this, let's move them all into, oh, there we go. Okay, so how many fit into 1? 4, okay. And that's even for all of them, right? We don't want any that are off or left on their own. Okay, 1, 2, 3, 4, awesome. And this last one, 1, 2, 3, 4. So you want to make sure that each x has the same number because the x's are all the same. Okay, so we have to figure out, okay, in 1x, and this one, how many ones fit in there? Okay, in this 1x, how many ones fit in there? Okay, that way that all of these x have the same number of them. Well, we were able to fit 4 ones in there, but were they positive or negative? They were negative ones. So it's actually x is equal to negative 4, which if we go back up here, that's what we found before too, right? X was equal to negative 4. So we know that we did that correctly with our model. All right, so another way to look at this is going to be the final way. So let me say I've got 3x equals negative 12. And what this is pretty much the way we're going to solve these for the whole unit. So this is a very important one. The equations line is like 2 specific fields, okay? They're 2 different spots. If I put up a scale right now, okay, which we use a lot to describe equations, right now my scale is balanced, okay? They're on the same level. The thing is, I have 3 x's over here. 1x, 2x, 3x, okay? And then I have 12 ones over here. There we go. Okay, I have 12 little boxes. So we know that they're going to be equal, okay, which means that the scale is balanced. Okay, so what we want to figure out is how many of these little pieces are in each of these boxes. All right, well, if we have 12 over here, there has to be 12 pieces over here too. Okay, we just don't know how many are in each of these mystery boxes. Okay, but it's got to be the same amount in each box because each box is the same variable, which means they have the same amount. Okay, that's super important to remember. Okay, so now if I look at it, all right, so we got 3 boxes. Well, how many can I fit in? We showed that with our model. Let's figure out how we can show that using opposite equations. So what I always do when I'm solving equations is I look for the variable. Okay, that's what I need to get on its own. I need to isolate it. Okay, I need to get it on its own on one side. Okay, so right now it's hanging out on this side, but it's got a buddy right now. It's got the 3 as its buddy. We need to peel that 3 off of that x because we only want the x on its own. Okay, we want it to be by itself on this side. So how do we get x by itself on this side? Well, what is this really saying? This is 3 times x. Okay, 3 times x. Okay, so how do I get rid of something? So let me use opposite operations with addition and subtraction to show you. Okay, 3 plus x. Okay, how do I get rid of the 3? Okay, so I have something plus 3. Actually, let me write it a different way so it makes a little bit more sense. Let's go x plus 3, which means the same thing, but it'll make a little bit more sense. X plus 3. Okay, so even without the x, there we go. All right, so let's say I have plus 3. Okay, how do you get rid of plus 3? How do you end up with 0? If I have plus 3, well, I have to take away 3, subtract 3, and I'm left with 0. Okay, perfect. So plus 3 minus 3 is 0. Okay. So if you notice, the opposite operation to addition is subtraction. Now, the same thing goes for subtraction. If I have minus 3, I'm missing 3, I have to add 3 to get 0. Okay, so I'm using the opposite operation. Okay, that is going to be this method, opposite operation method. And that's going to be the method we use this whole chapter. Okay, so this one's very important. So opposite operation. So now when I look back up here, I need to use the opposite operation. But notice I'm using a different operation. I'm using multiplication, 3 times x. So how am I going to get rid of the 3? Okay, well, what's the opposite operation to multiplication? It's going to be division. Okay, so now instead of going 3 times x, I'm going to divide it by 3. Okay, what's 3 divided by 3? That's going to give me 1. Oh, 3 divided by 3 is going to be 1. So all I'm going to be left with on this side is 1x, which is exactly what I want, right? I just want 1x on its own. Fantastic. The only problem is, let's pretend I have my scale. All right. And right now my scale is even. All right, and it's got 3 apples on each side. Let's say I take away these 3 apples from this side. The scale is no longer going to be balanced, right? It's going to lean forward this way because this one has 3 apples and this one has nothing. Oops, the other way. It's going to be heavier on the other side, sorry. There we go. This one's going to have 3 apples and this one's going to have none. Okay, so it's going to be heavier on this side, so it's going to be unbalanced. So what would I have to do to balance it out again? I'd have to take away 3 on this side. All right, and now I would have a balanced scale. Okay, it would be even. So whatever I do to one side, I have to do to the other side. And you're going to get so tired of me saying that, okay? But what I do to one side, I have to do to the other side. So when we go here and we look at what I just did, I divided by 3. 3 divided by 3 gave me 1. So what I was left with on this side was 1x, which is exactly what I wanted. I got x by itself. Okay, but if I divide by 3 on one side of the scale, I have to do it to the other. So I have to divide this side by 3 as well. Well, what's negative 12 divided by 3? Well, that's negative 4. And so what we end up getting is the exact same answer. X is equal to negative 4, right? We were just able to get this answer in 3 different ways. Okay, so we're able to start with fact families, right, which is exactly what we did, 12 divided by negative 3, and that's why it works. We were able to model it, and then we were able to use opposite operations to isolate and get that variable on its own. Okay, so there's a lot of important vocabulary when we're solving equations. Okay, now there's one more type of equation that I wanted to show you, and this is the, let's say, r divided by negative 2 equals negative 7. Okay, r divided by negative 2 equals negative 7. So it's a different type of equation. So now let's use our fact families first to solve this. So we've got r, and let's remember, don't forget that this symbol means divide. So this is r divided by negative 2 equals negative 7. Okay, so let's use our fact families. Okay, so if we're going this way and it's dividing, then going back this way would be multiplying. So we're going to go negative 7 times negative 2 is going to equal r. Negative 7 times negative 2 gives me 7 times 2 is 14. Negative times a negative is positive. So r is going to be positive 14. Okay, so that's going to be our fact family method. Okay. The second method is the model method. Now, it's not going to use integer triers. We're going to use little fractions. Okay. So I'm going to draw a circle because I have to represent this fraction, r divided by 2. Okay. And actually, is it r divided by 2? R divided by negative 2. Okay. So this is going to be a negative. Okay. Also, a helpful note for those of you that don't know, negative r divided by 2 is the same thing as going r divided by negative 2, is the same as just negative r over 2. Okay, these are all the same thing. Okay, you can write them either way. Usually we write the negative on the top. Okay, so that's why I rewrote it here. Okay, so now here's the thing. I'm going to draw this fraction. We got something over 2. We don't know how many, but we got it over 2. Okay, that's going to tell me what I need to split this up into. Okay, now 1, if I color in half of this, just 1/2, it's going to equal what? Well, we know negative r over 2 is equal to, what was it equal to? It's negative 14, correct? Negative 14, was that? Oh, no, it was negative 7. There we go. Okay, so now this fraction, okay, this circle that we drew, that half, that has to be equal to negative 7. So we got 1, 2, 3, 4, 5, 6, 7, negative 7. Okay, and I didn't color them in because they're negative. Okay, so now here's the thing though. We got negative r over 2 is negative 7. But the thing is, only half of this is colored in. I want all of it colored in. So how many more times do I need to have this? If half of it is 7, I need another half. That's going to be how many more? Oh, another negative 7. Okay, so in total, what do I have here? I have negative 14. And what do I have here? I have a hole. That's great. Okay. But is it a positive hole or a negative hole? Let's check that r. Oh, it's a negative r. Okay, negative r equals negative 14. Okay, this is a tricky part. Okay, a lot of people get confused here. Go, okay, well, this r is negative. Okay, this is negative. The cool thing about it is if both numbers are negative, you can get rid of the negatives and you're going to be left with r equals 14, which is what we got first. Okay, the reason for that is, for those of you that want to know, feel free to, you can look it up. Okay, but really what we're doing is we're dividing by a negative 1. Okay, so negative r divided by negative 1. The negative cancels out. Negative 14 divided by negative 1. Negatives cancel out. We're left with 14. Okay, but what you need to know is if this is negative, this is negative, you get to get rid of them. Okay, so r is equal to 14, and we got one more method that we're going to do it with, and then we're done. So negative r over 2 equals negative 7. So this is the third method. This is using opposite operations to isolate the variable. So we want to get this r by itself over here, okay? So I draw my fields, great, my scale, okay? I got negative r divided by 2. Okay, so I'm taking this, it's like I'm taking a box, Okay, that's r, that present. We don't know how many's in there, and I'm splitting it into 2. Okay, and in half of it, we've got -7. In the other half, we have to have -7. So how many do we have in total? Well, we have -14. Okay, so that's what we're doing with the model. Okay, but using opposite operations, we're going to look at what operation are we using here. What does this line here mean? Well, that means division. Okay, so we have to use the opposite of operation to division to get rid of this 2. Okay, so what's the opposite operation to division? Multiplication. So we're going to multiply by 2. So instead of dividing by 2, we're going to multiply by 2. When we do that, this is kind of what it actually looks like. What's the denominator on a whole number always when we multiply fractions? It's going to be 1. So when I multiply this, I get -2r over 2. And -2 divided by 2 is -r. So I'm left with that r by itself. Perfect. So my job happened. Okay, so this part here that I just did, this shows you why the opposite operation works. Okay, so why multiplying by 2 ends up just giving us the -r. Okay, gets rid of that 2, whatever it is. Okay, so we have -r is equal to, and now hold on. What did we do up here? What was that operation? We multiplied by 2 on one side. So what do we have to do to the other side? We have to multiply by 2. -7 times 2 is -14. So now all we're left with is -r equals -14. But we just learned, oh, if we've got 2 negatives here, we can get rid of them. Okay, and we're left with r is equal to +14, which is what we figured out before. Okay, so if you are a lot of information, this is kind of the most basic solving of equations. There's 2 different types, so if you are a little bit confused, feel free to come to the tutorial this week. I'm going to reteach all of this week during the classroom periods. That's a really good thing to attend because I'm going to do more types of practice questions. Okay, so I strongly encourage you to go to your teaching hours. Okay, and if you have any questions, come to the tutorial as well. Okay, I'm happy to do more questions of this type with you, but this is kind of the overview of how we're going to do it.